예정보다 5분 늦게 15분에 시작하는 걸로 하겠습니다. 일단 시작하기 전에 점심 식사들을 하셔가지고 되게 졸리거든요 지금. 그래서 가능하면 좀 피곤하실 때 스탑해가지고 쉴 수 있도록 하려고 하는데 계획상으로는 지금 2번 쉬게 되어 있죠. 저쪽에 밖에다가 음료는 물하고 쿠키 정도 준비를 다시 하기로 했거든요. 그거 참고하시면 되고, 그 다음에 이분들이 지금 보여주고자 하는 거는 사실은 여기 그림에 보이죠. 그래서 우리가 제일 관심 있는 시스템이 잘 정의가 돼야 되고요. 뭔가를 해결하려면. 그 다음에 더 중요한 게 있죠. 우리가 저 OMSMP라고 하는 운영 시나리오가 어떻게 되는데, 이거에 따라서 시스템의 성격이 바뀔 수도 있고, 거꾸로입니다. 시스템에 따라서 이놈의 성격이 바뀔 수도 있고, 따라서 이 두 개가 서로 상호작용을 하면서 우리가 원하는 어떤 결과들이 계속 변동이 생깁니다. 그걸 일단 염두를 주셔야 되고요. 사실은 더 중요한 게 있죠. 우리 저 지원 체계에 관련된 구조들이 어떻게 변하느냐에 따라서 또 두 개가 또 영향을 받을 수도 있는 겁니다. 어쨌든 이 세 가지 요소가 서로 상호작용을 해서 우리가 원하는 어떤 결과를 얻어내는 거니까 이 세 가지를 스텝 바이 스텝으로 모델링을 하는 게 상당히 중요한 기죠. 의미 있는 결과를 얻을 수가 있다는 얘기죠. 겨우 저 반나절 했는데 저 시스템 얘기하다 끝난 겁니다. 사실 지금까지. 시스템 고장이 뭐야? 그 다음에 고장이 났을 때 어떻게 할 거지? 요 정도까지 지금 얘기가 된 거고, 이제 요런 것들을 조금 더 디테일하게 얘기를 계속할 예정입니다. 오케이? Ready?
I'm ready. So, hello everybody again. Hope you had a nice lunch. Let's continue the seminar. Now we had focused a lot on the technical system, and we have modeled properties of the technical system, that is the product breakdown, but also failures. And these are properties of the technical system that undoubtedly belongs to that entity. Also, maintenance procedure of how to address the failures on the technical system is also a property belonging to the technical system, and when it comes to this picture. Now we're going to shift focus and look at the support organization and how we typically build up that in the OPUS suite world. In OPUS 10 we have four predefined support elements, support organization units, or stations as we call them. Workshop, depot, store, and operating base. These predefined types have some properties. In a workshop, in the OPUS suite model, you can do item repair, but you're not allowed to store any item stock. So this is typically, you could imagine that if you are an operator and you send an item away to be repaired and you receive it back, the entity that you send it to would typically be a workshop, because you as an operator are not interested in if the workshop keeps any spare parts or not. From your perspective, the only thing that matters is that how long time does it take till I get it back, and how much does it cost? If they have 10 or 1 million of the items in stock, you don't care because you're not responsible for the workshop. But you want to know how long time it takes to get an item back once it's sent there, and how much you have to pay for it. A depot is a place where you can carry out item maintenance, item repair, and store spare parts. This could typically be your own workshop that you own and carry out some maintenance activities, but you're also interested in optimizing the spare part stock in this location. What spare parts should we have on the shelves in our stock, in our repair facility? A store is a place where you can't perform item repairs, but you can stock. So this could be a local warehouse serving some operational units where you have some forward spare part in stock, but it's purely a storage facility. It's not possible to conduct any item reparation activities there. And the operating site is a location where you don't perform any item repairs and you can't store any items either. And that's typically a location where the systems operate. And I said no item repairs because you will be allowed to remove and replace broken items from your system at this location anyway. So when I'm talking about the repair, it is item repair. And why do we have these building blocks defined in the organization, you think? And why are they so, why do they have these properties? Well, when you are going to perform a spare part optimization, you need to tell the model in OPUS where it can store items and where it cannot, in order for OPUS to understand, okay, this is a workshop, I should not evaluate the benefits of putting any spare parts in store here because it's not allowed. So in order for OPUS to make a sensible spare part optimization, it must know where it is allowed to stock items.
But we usually have some spare parts in the workshop. We usually have some spare parts in
Probably.
the workshop. Yes.
There are probably spare parts.
Yes. And the spare parts are separated in the post site and in the workshop places are separated.
Mm-hmm.
But you assume that in workshop, no repair and no storage.
Mm-hmm.
You assume like that.
But this is just from the model perspective. So if you have a workshop where you store items and you are interested in calculating these items, you should model it as a depot.
And therefore,
Exactly. So this is the entities. If you want to model a place where you only repair, then you should model it as a workshop. If you know that I'm interested in both the repair and the item storage, then you should not model it as a workshop, you should model it as a depot instead. So it depends on what you want with your modeling. It's always the perspective, as I explained in the beginning. If I am the operator and you are the supplier and you give me a contract on repair, and okay, I say I send the broken items to you when they are to repair. I don't care if you have a stock or not, but you give me a price and a lead time. and I receive. That is what interests for me. But for you, it's more interesting to know how much you should store in spare parts in order to respect the contracted lead times. But if I do the analysis from my perspective, I don't want to calculate what you have in store. So you see the difference. These are building blocks, and together you can use them to build up, like with the product breakdown, a hierarchy, a structure of your support organization. And this is also, you can build how many you want on the same level, how many stations that you want on the same level, and how deep you want as well. So this is just an example.
You mean that workshop is more bigger place or bigger facility than depot?
Sorry, that
Yes, the workshop is upper, so it means that workshop is more bigger places.
Not
than
necessarily.
depot.
Not necessarily. We could say that if I am the operator here, I own the depot, the stores, and the operation site. But I'm not responsible up here. But as I said, this is a repair place which I send my things to and I get them back. So this is what the workshop here illustrates. It could be multiple workshops as well, because I send different parts to different suppliers. But it symbolizes the fact that I get repaired items back, but I don't build up any stock there, not from my perspective. You, as a supplier, will probably build this organization from a different perspective.
Usually in Korea, depot is the last place. Maybe different.
수명해야 될 것 같아요.
오해가 생길 것 같아요.
여기 워크숍, 데포 이렇게
이렇게.
네 가지로 이렇게 구분을 해놓은 거지 이게 답은 아닙니다. 뭐 기분 나빠서 오퍼레이셔널 사이트 X가 있어요. 나 여기다 스페어도 갖다 놓고 여기서 리페어도 할 수 있어요. 지정하기 나름이에요. 그냥 이건 예다 이런 뜻입니다.
제가 아까 드렸던 질문은 스토어에 해당하는 거.
뭐 워크숍은 수리만 한데 스페어도 둘 수 있어요. 그거는 이제 내가 지정하기 나름이지. 이건 하나의 일러스트레이트다 이렇게 얘기했잖아요.
우리가 보통 대포하면 창이라 그래서 맨 마지막 수도 있는데 그게 워크숍은 뭐가
예, 뭐 아무튼 내가 하기 나름이다. 정해진 건 아닙니다 이거. 지금 유시가 뭐예요? 첫 번째가 리페어냐, 둘 다 하는 거냐, 하나만 하냐, 둘 다 안 하냐. 네 가지 경우의 수가 나오죠. 지금 따지면 기자님 아무것도 안 하냐, 둘 다 하냐, 하나만 하냐. 그러니까 경우의 수는 네 가지고 네 가지 예를 이렇게 든 거지. 꼭 워크숍이니까 뭐 리페어만 하고, 데포니까 수리도 하고 리페어도 있고 저장도 하고 이런 뜻은 아니다 이런 뜻입니다. 사용자가 그러니까 분석하는 사람이 지정하기 나름이다 이런 뜻입니다. 지금.
여기 다음 페이지에 보면 좀 다르게 설명을 이렇게 해놨어요. 그 워크숍이 데포 레벨 같고 이게 아마 I라고 하는 게 인터미디어트 같은데 인터미디어트 레벨을 여기선 데포라고 적용하고 있으니까 우리가 보통 생각할 때 워크숍을 데포라고 생각하고 그 밑에 인터미디어트 전기체계라고 보면 될 것 같아요. 우리가 좀 다른 그러니까 네이밍이 좀 다른 것 같아요. We understand.
I mean, it's good to point out as well that you could have depots everywhere here. You could deploy a system to a depot. It depends on what capabilities do you have on what place in your organization. It is, you're totally free to decide that in your model. This is just an example how it typically could look like. What we have here also that we need to address in our support organization is the transportation time between all these entities. Because in the OPUS model, you are typically, the flow of spare parts is, the spare part demand is generated at the sites where you have systems in operation. And in an organization like that, the demand is propagating upwards. So if I get a demand for a spare part here, I ask the closest spare part location. Here I get the spare part. The broken spare part goes here and continues up to the depot. If it is repaired there, okay, then it's sent back and put on the shelf here. If it's repaired up there, it needs to continue and be repaired up here and then sent back to put on the shelf here and wait for the next demand. So that is in a very simple way describing how it goes. So all demands that occur needs to be taken care of somewhere in the organization. Otherwise you will get an error, say this is unhandled demand somewhere a demand that cannot be, that we don't know what to do with.
I have a question.
Mm-hmm.
Does the structure is the physical relationship between the sites?
Yes.
Mean that if the system have failure, does it on the operand site X, does the system have to go to default via store A? Is there any route directly to the site X to the default?
Yes, you could probably. Yes, you could have different transport policy for individual items or individual systems. So you could have a general structure like this that you can override with specifically to say, for example, when the engine breaks, it goes directly to the workshop, and you don't have to transport that way. So you can, yes, you can model it that way.
In that, I have another route to the operand site X to the default directly in multiple route between two sites.
Yes, you could model that. You will set up the general rule, and then you can specific, what you say, other variants that are bypassing that route, that general route. So it's possible. Yes, the short answer to your question is yes. You remember when we made the maintenance tasks, we talked about maintenance levels, what kind of complexity a certain task require. And this is something that we also assign to our maintenance organization. Each station needs to have a certain maintenance level. So in that way we can see what kind of tasks can be performed where. And you can decide your own maintenance level, how many maintenance level you want. But just to illustrate operating level, intermediate level, and depot level, you can say here.
The last level may be organization level, and the intermediate level, and the depot level. So I asked previously the final stage is depot. So usually in Korea, the workshop is on the depot.
Mm-hmm.
Also, in workshop, we usually do intermediate level maintenance. And in depot level, in that case, workshop level, we repair and have some storage too.
Yeah, that would be possible.
So you define in workshop, we repair and bundle storage. Some difference in our situation. So we must understand under the
What is built in the model, however, is some inclusiveness in hierarchy. So you remember we said the different maintenance level got numbers 1, 2, 3, 4, 5, depending how many maintenance level you have. And that means that you can perform O-level tasks at an I-level station, but not the other way around. It's not possible to perform I-level task at an O-level station. So the higher up in the maintenance level hierarchy you come, the more capability you have to perform maintenance tasks. So D level in this case can do everything you can do on I level and O level. So, if we go back to the model and have a look. We are now ready to take the next step. And now you can see that we finally got a nice maintenance organization here. And in the first case, you say we had products and items that we filled out. Then we added failures and maintenance. And now we add organizations. Oh, we should remove that one. That is SIMLOX. So organization as well. And here you have a set of tables that's used to build up the maintenance organization. So you have station, where you define all the locations, all the entities that you have in your organization. You set if they are depot, workshop, store, operating site. And you can specify also some more properties here. Also some cost values on storage, etc. So a list of your locations, and then in a hierarchical way you describe how they are related and how long the transportation time is between the different stations. You also describe in a table called maintenance capability here what kind of components that you can perform maintenance on for different stations. So for example, before that we have made use of the group concept in order to facilitate input data. So we have created a base group here which consists of all the bases. So each time we want to assign something to a base, we don't have to take it once for the main base, once for base alpha, one for beta and gamma. We can just refer to the base group because it's applicable for all of them. And that's exactly what we have done here in maintenance capability. We said that variants are the system variant, the product. On the base group, here we conduct maintenance level 1 activities. So in the same way, we have added component group and component group content, that we can say that the variant group consists only of the variant. We have the product variant. And then we have a group called primary items, which consists of all the items. And then we have two separate groups for the engine and the gearbox. So now we can use them and model in a more compact way here. You can see primary items at workshop, that is maintenance level 3 activities. Gearbox and engine, for example, at the central location, that's where you remove the modules. That's maintenance level 2 activities. But engine in the workshop, that's maintenance level 3 activities. And if we then go back to the task table and have a look, we can see that for the engine, replace a module is a maintenance level 2 activity, and to repair an engine module is maintenance level 3 activity. Maybe a little bit too much to keep in mind right here, but to use these grouping functions, we can more quickly address, because imagine that you have 100 items, you can't write one line for each item. It's better if they are treated the same way, you can treat them by using the group concept instead. And there was this question about if you could do a specific route for a specific item here. You see the table station structure that describes the structure here. We do have a table that says item station structure. So let's say that for the engine, we have direct connection between the main base and the workshop. And it takes 24 hours back and forth here. You can see if I select the engine here, it gives me, maybe not very beautifully, but the access directly to the workshop for that engine. So there is a possibility to override the general structure for a specific item, but if you go to all the other items, they follow the normal route. But here we have a special route for the engine. Just as an answer to your question.
Yeah.
And that's a common concept in Opus Suite. You have one table that you describe a general approach, a general rule, and then you have tables that allows you to override that rule for specific cases. Questions? Sorry, I was not. Okay. I'm not sure I captured your question entirely. Do you mean if you have different groups that contain that the group can contain another group, or?
Maintenance level. If I want to divide it 4 to 3, can I integrate it back maintenance level?
Yeah, I think so. You could probably do that. If I understood you correctly. It is a very free concept of both the maintenance levels and the groupings. You can create groups in the ways that we have done here, but you can create groups of groups as well, so that you can separate, for example, primary items into several subgroups, and then you could create one overarching group that consists of all the subgroups. And I mean, here's, for example, you have also a group, the engine and the gearbox, they are both assigned to central and the workshop, maintenance level 2 and maintenance level 3, because for items in this group, you will have activities of both complexity, both maintenance level 2 and maintenance level 3. And this will then automatically be taken care of by the model, because it says that, okay, for all level 2 activities, this will be carried out at the central, and all level 3 activities, this will be carried out at the workshop. And I don't have to be more specific than that.
In that case, the workshop is a level 3.
Yes.
Always describe the level 3. And central is level 2.
Yeah.
And the base group is level 1. You did like that.
Base is level 1.
You define workshop is more higher level than
Yes.
central. So I think workshop may be level 2 and the central may be level 3, like that. Yeah.
Was there another question?
displays the other parameter.
The other parameter here, endurance.
No, the other. Order. Order.
The order
Yeah.
in this table.
No. In this case.
I'm not completely sure I understand what you mean.
Yes, in this model, it needs also real point.
Yes.
SS powers like that.
Yeah.
But this is just like a maintenance side, not supply side.
Reorder, you talk about reorder.
Yeah.
Okay,
Just
sorry.
explain the maintenance side. But I have some confusion and the central and workshop there because it's different from Korea. But he just explained maintenance side, not supply side. Later part, he will explain the supply side too. There are so many real policies, SS policies like that. And as far as I know, this local OPUS to follow the SS policy. When we reach the S point, you start to reorder large S, small S like that. But he just explained maintenance side.
We could add a table here, if we're allowed to play around a little here. It's called reorder capability. So far we don't have any reorder at all in this model. So I add reorder capability. And let's say, for example, that for this APU, we don't perform repair. So I will deactivate this row. You see it turned white. Instead, I say for APU, we order a new one to the central store. And the lead time is 730 hours. So in this case, I select the APU. You see here, you have reorder of APU at central. And I need also to specify that this failure for the APU is not repairable. Repairable by default, yes. You can see it turns blue because this one is non-repairable item and it will be reordered to the central here. So each time the APU breaks, we will get one from the stock, and eventually we need to buy a new one to replace the item that was taken from the stock.
In this example, so according to this example, the engine is replaced on the central and repaired in the workshop, right?
Yes.
It means that when a failure happens, it extracts the engine from system on the central, and the engine is repaired on the workshop.
Actually, if I select the item here, I can see the repair policy here in the organization chart. So I can see here that replacement of engine invariant at the main base. So I do a replacement task here. I send the engine here, where you can replace the different modules at the central. So the engine is repaired here by removing a faulty module and replacing with a new one. But we also have the possibility to replace the engine modules up at the workshop. But this is not, since we don't keep any spare parts up here, in reality, all replacements will be done here. But this is the policy for the engine. Removal of engine down here, removal of engine module here, and repair of engine module. If I check the engine module, you see it's removed here and repaired up here. And if I take the engine primary item, removed here, remove module here, and yeah, typically it's possible to remove the modules there as well.
My question is, when the engine goes to the central and repair on the workshop, through the route, the moving parts is different according to the route and maintenance policy. So does it, the transportation cost is considered by parts or like?
Yes. So this is the cost. The cost is incurred for the engine to be transported up to the central, and then for the modules to be sent up to the workshop and back.
Means the different cost is adjusted in each route.
Yeah.
Yes, you can. You can have central, so you have the same for all parts, or you can have it specifically for each part. So each part can, in theory, have its own resupply structure and times and everything, but normally you have groups like that. So you have some parts have one time and others have others. But you can be very detailed if you need that.
But in the case, it may be hard to calculate or measure the transportation cost because it is separated side to side. We do not have such kind of transportation there. So it's one of the problems to calculate or measure the transportation cost. Just like he asked, if the transportation cost is separated in the route, it may be hard to measure all the transportation costs. Understand?
Yeah.
Yeah.
You could have. You could also have in the simulation tool in SIMLOX. You can work with batched transport, that you are performing the transport when you have a certain number of items to transport, so you don't go one by one in order to, which probably is more applicable to some real cases. Okay, so now we have a case where we actually have the product, we have the support organization. So we're missing one part now, the last part. And this is the operations. And to explain how that works, we need to start at the product variant, because so far we have described products, but there is a distinction in OPUS Suite between a product and a system now. So the definition of a system now is actually a deployed product. So you see the difference? It is a realized product. And to exemplify what I mean by that is, you could have a product described, a product variant described in the model, on which, for example, you have an engine that can be realized by 3 different engines. You could have one product variant that has an engine, either diesel engine or fuel engine or electric engine. That's when you buy a car. You can say, okay, I want to buy this car, and often the supplier gives you the possibility to choose what kind of engine you want to have in your car. It's the same car, but it can be implemented in different ways. So the same product variant, but when you buy it, it can't have 3 engines. You must choose one of them. And that's when it becomes a system. So you can say, okay, on this base I have 10 systems that have engine type A, and that's what you specify. So the product variant is more of the configuration of the product. So instead that for having to configure 3 almost similar products in your model, it's enough with 1 product variant that gives you the possibility to choose between 3 engines, and then you have to tell the system when you are actually putting systems in operation, we need to specify what engine is it that you mean in this system. So this is the difference between product variant and system in OPUS Suite.
And it follows the ASD standard constantly, so that's kind of how it works in the new S series.
Yeah, that's possible. Yeah. And they are deployed on operational site, but you can deploy a system also on a depot or on a store, etc. So it's not necessary that you deploy a system just to a station of type OPSite. But that's the place where you deploy the systems, that's where you have operations going on. You could also create units, operational units, in order to make distinctions from operational profiles. It doesn't have any impact on the logistics or anything like that, but from an operational perspective, I can assign my systems to 2 different units because I want the units to conduct different operational tasks. But they are both, you can imagine an air base where you have different squadrons. The squadrons are units, the air base is the operational site. Then we have to, that was the number of systems that are deployed. Then we have to tell OPUS how much are we using the systems. We need to give them an operational profile to execute on, an utilization profile. And you remember I said that OPUS 10 is a deterministic steady state tool. We don't have the dimension of time. Everything is average here. We calculate average transportation time, average repair time, etc. And that goes also for the utilization. So we have to give an average utilization time per year. So we give that as, for example, number of flight hours per year. But we can also specify how many missions that is per year. So 250 flight hours per year, 52 missions. That gives an average, that gives 4.8 flight hour per mission. But in OPUS calculation, it will only base the average on the average utilization, because it doesn't know exactly when the missions take place. But if you, for example, have modeled some kind of scheduled maintenance that takes place every 10th mission, then this is information that can be useful, because then OPUS will know how many times this scheduled maintenance will take place. But the concept of mission will make more sense tomorrow when we are talking about SIMLOX and the simulation in time. And this also poses some questions on how you should think when you model in OPUS 10. Let's say that you have a scenario where, if you look at 1 year, we are going to run the system 100% for 6 months and nothing from the last 6 months. Is that the same as saying that we are running the system 50%, 12 months? Do you think that the dimensioning the stock and the maintenance organization for 50% usage, 12 months equal the scenario where you run 100% 6 months and 0% the other 6 months. I saw someone, you're nodding your head there, and that's totally correct. Why? Because you would probably have to instead look at the horizon of 6 months, skip the last 6 months and look at what does it take to run the system 100% 6 months. That is what I need to do in order to dimension my spare parts, not for an average usage of 50%. So that's to be careful when you are putting in the scenario length in OPUS 10 to calculate. Should be careful. What is the horizon? What is the usage over that horizon? For what kind of situation do I want to dimension my maintenance resources? When you go into the simulation world, you could take this approach over 1 year, because that will be interesting to see after the 6 months what happens. How long time does it take to rebuild the capability after 100% utilization the first 6 months? That is an interesting analysis to do. But to dimension the support response for 100% utilization, you should only look at the 6 months. So, back to our model again. So here we are, and now we have added operations. You can see here we started out products and items, then failure and maintenance, added the organization, and now we have a last case where we added the operations. And you can see here the table system. I say that we have a system identifier that's based on variant A. In this case, we don't have any choices of, for example, engine to implement here. So the system, the product variant looks the same and is directly mirrored to the system. There's only one way of implementing this product variant. But if I had this possibility to choose, there is a table called system realization that tells me exactly what item I use for this system at a certain position. So I can show you briefly afterwards how that is done. But in this case, we don't have to specify that. So we have a system out of memory. What happens now? I don't know. I will try to restart it. Maybe I had. Things like that happen sometimes with software.
Break time?
Break time, maybe. I think I will just have it a quick go and.
잠깐 쉬시죠.
We take a break?
Yeah, take a break.
Yeah.
Task manager.
Yeah, I will go into Task Manager. Jag vet inte.